We've been doing a lot of practice with trig identities, and I'm going to give you just a few more. There's actually a lot more identities, but we're not going to talk about all of them. I'm only going to give you the ones that I think are the most important for future math classes. So the first one is, it's called the double angle formula, and double angle formula means if you have 2 times your angle. So sine of 2 theta is my first one I'm looking at, and that's going to be equal to 2 sine of theta times cosine of theta. The second one that's important is cosine of 2 theta is equal to cosine squared theta minus sine squared theta. And actually, the second one with cosine, you can actually rewrite it. We know that sine squared theta plus cosine squared theta is equal to 1. So if you were to replace sine squared theta with 1 minus cosine squared theta, you would get an alternative identity, which would be cosine of 2 theta is equal to 2 cosine squared minus 1. If you did the same thing, except now you solved for cosine squared and replaced it with 1 minus sine squared, you would get 1 minus 2 sine squared theta. So I just want you to be aware of these. The top two are the most important. However, I think it's helpful if you also recognize the bottom two. The first type of problem you might see with these is one where you will be given a sine or a cosine or something else and a domain, and you're going to have to find sine of 2 theta and cosine of 2 theta. So keep in mind that sine 2 theta is equal to 2 times sine theta times cosine of theta. We already know, and because we're given, that sine of theta is equal to 3/5. So that's a start. We do not know cosine theta, but we can find it by using stuff that we've learned in previous sections. So the first thing that they tell us is that we are in the second quadrant. Remember, this is 0, this is pi over 2, and this is pi. So we're in the second quadrant, and we know that our sine is 3/5. So I'm going to go ahead and just draw an angle here. I know that sine is opposite over hypotenuse, so it's going to be 3/5. I'm not going to do the whole Pythagorean theorem. This actually is part of a Pythagorean triple, meaning that I get a whole number for my other side. The other side is actually 4. And that side right there is going to give me my cosine, so that's going to help me out. So I know that my cosine is 4/5. However, you might have noticed that I made a mistake in here. I did that on purpose, by the way. So actually my cosine is not positive 4/5, it's negative 4/5 because I'm in the second quadrant, so it's going to be negative. Be really careful about that. The signs are what messes people up the most on these types of things. And if you multiply everything here out, you should get negative 24/25, and that's going to be equal to sine of 2 theta. Now for cosine of 2 theta, we actually have 3 formulas. You can use any of the 3 that you like. I will use the first one, although I do think that bottom 2 might be slightly easier because you have fewer things to substitute in. But use whichever one you like the best. I like the top one the best. I think it's easiest for me to remember. So I know that cosine of 2 theta is cosine squared theta minus sine squared theta. Remember, cosine squared theta, easiest way to do that is to do the cosine first and then square it. So I'm going to do negative 4/5, and then that's going to be squared. For sine squared theta, I'm going to do 3/5, and then that's going to be squared. So that's going to give me 16/25 minus 9/25 which gives me an answer of 7/25. And actually, if you do either of the other two formulas, you're welcome to do it and try it, you will get the same answer. So the second type of problem we'll have in this section is establishing the identity. Looking at this one, it looks really hard, but it's not too bad. It doesn't have a ton of steps. So what we're going to do is we're going to solve this like any other establishing identity problem. I like to start on the most complicated side, and that one definitely is the right-hand side. So it's always a good idea if you're stuck and you see like secants or cotangents or anything like that to get them in terms of sines and cosines. This one, I'm going to write it as cosine 1 over cosine squared. That's on my numerator. The denominator is going to be 2 minus 1 over cosine squared. So then, and that's equal to secant of 2 theta. Next thing I'm going to do is multiply the entire equation by cosine squared over cosine squared. The reason I'm going to do that is because in my numerator, my cosines are going to cancel out, and I'm just left with 1. In my denominator, I do have a little bit more. I have to distribute that cosine squared theta. So I end up getting 2 cosine squared theta minus 1. But actually, that is already an identity that we have. That is the same as 2 cosine squared theta minus 1 is the same as cosine of 2 theta. And 1 over cosine of 2 theta is just going to be the same as secant of 2 theta. So we're done on this one.